Um, this video is about conservation of momentum. Now, the law of conservation of momentum says that the momentum must be conserved in a collision or an explosion. Now, when two things collide, their total momentum before must be equal to the total momentum after the collision. So, in order to illustrate this, we're going to consider this example. Suppose we have a trolley of mass m moving with a velocity u, which collides with another trolley of mass m2, and after the collision, the two trolleys, they stick together and they move off together with a common velocity v. Now, we want to find what this common velocity is, and also the loss of kinetic energy in the collision. So we're going to use the principle of conservation of momentum to work this out. Momentum before the collision is equal to this trolley is mass is m, moving with a velocity u, so its momentum is going to be m1 times u1. So we say m1 u1 plus, now here we say u2 is greater than u1, because this has to be faster in order to catch this one up and collide with it. m1 u1, the momentum of the second trolley is m2 times u2, is m2 u2. Now that must be equal to the momentum after the collision. Now after the collision, the trolleys, they stick together and they move off together as one body. So the two masses will be combined, m1 plus m2, which is m1 plus m2 times by the common velocity v. Okay, so this gives us a formula for momentum before and momentum after. Now, suppose we do an example. If m1 was 2 kilogram, a trolley of mass 2 kilogram, moving with a velocity of 5 meters per second, collides with a trolley of mass 1 kilogram, moving with a velocity of 2 meters per second. What will be the velocity after they stick together? What will be their common velocity? Okay, m1 is 2 times u1, which is 5, plus m2, which is 1 kilogram, times u2, which is 2 meters per second. That must be equal to m1 plus m2. That means that's 2 kilogram plus 1 kilogram. Okay, they stick together. So it's going to be 2 plus 1 times by v. Okay, 5 times 2 is 10. 10 plus 1 times 2 is 2. 10 plus 2 is 12. So that comes to 12 equals 2 plus 1, which is 3, 3v. Therefore, v is going to be equal to 12 divided by 3, which is 4 meters per second. So the two trolleys, they move off together with a velocity of 4 meters per second. Now, we know that the momentum is conserved. What about the kinetic energy? Is kinetic energy conserved? Now, energy is always lost in a collision or an explosion, because energy can be converted into other forms. So let's consider kinetic energy before collision. no, this is given by the kinetic energy of the first trolley, which is, no, remember the formula for kinetic energy is half mv squared. It's a half times the mass of the trolley, which is 2 kilogram, times the velocity squared. The velocity is moving with a 5 meters per second squared, is 5 squared, plus the kinetic energy of this trolley, its mass is 1 kilogram, plus a half times 1 times the velocity is 2 meters per second, so times 2 squared. Now, if you work that out, 2 into 2 goes once, that cancels out. 5 squared is 25, to 25, and 2 squared is 4. 4 divided by 2 is 2. 25 plus 2 is, that comes to 27 joules. So the kinetic energy before collision was 27 joules. Okay, now let's work out the kinetic energy after. After the collision, the two trolleys, they move off together with a common velocity of 4 meters per second. So the total mass is 2 plus 1, which is 3, and the velocity is 4. So it's a half times the mass, which is 3, times the velocity squared, which is 4 squared. Now 4 squared is 16, divided by 2 is 8, 8 times 3 is 24. So this is 24 joules. Now, can you see the kinetic energy after the collision is less than the kinetic energy before collision? So what is the loss of kinetic energy? The loss of kinetic energy is going to be 27, take away 24. Which gives you 3 joules. So 3 joules of energy is lost. Okay, what happens to that energy? Well, that gets converted into heat, light, could be heat or sound. Okay, we say converted to heat, stroke sound. Okay, because when they collide, they heat up, and also you hear the sound, so some of the energy is converted to sound. Right, okay. The next thing we're going to talk about is the explosion. The total momentum before collision is equal to the total momentum after. So we're going to consider a gun and a bullet. Now, what happens when we fire a gun? I'm going to draw a gun like this. That's the gun. And there's a bullet that's coming out of it. That's the bullet. Now, when the gun is fired, okay, what happens is if we say the mass of the gun is, say, we will call this mass of the gun, and this is the mass of the bullet. mg stands for the mass mass of the bullet. So the momentum of the gun, now what happens is, if this comes out with a velocity v of the bullet, what happens to the gun? Now remember, the momentum has to be conserved. So as the bullet comes out with a velocity v, it has a momentum to the right. Now, to conserve that momentum, the gun must recoil back. The gun goes back. So we say that the recoil velocity of the gun, Vg. So we say before explosion, the total momentum is 0. Okay. Before explosion, the momentum is equal to 0, and that must be equal to after explosion. Now, after explosion, what happens? The bullet moves off with a velocity Vb, so it's mass of the bullet times velocity of the bullet. Okay. Now, and the gun recoils. Okay, it goes back, so its velocity is going to be negative. It's going to be minus Vg because it recoils back in the opposite direction. So we said plus mass of the gun times velocity of the gun, which is negative. Right, now if we bring this on this side, this is minus mg times Vg. We'll go on this side. We say that mass of the gun times the velocity of the gun is equal to mass of the bullet times the velocity of the bullet. Now, to illustrate this, suppose the gun has a mass of 4 kilograms. The bullet has a mass of say 20 grams, which is 0.02 kilogram. Okay, we're going to convert this into SI units, and it comes out with a velocity of 100 meters per second. Okay, so we want to find what the recoil velocity of the gun is going to be. So mass of the gun is 4 kilogram. 4 times velocity of the gun, the recoil velocity of the gun, we want to find. Mass of the bullet is 0.02. Multiplied by the velocity of the bullet, which is 100 meters per second. Meters per second. So velocity of the gun, the recoil velocity of the gun will be, no, that times 100, that gives you 2. You move the decimal point 2 places, that's 2. And take the 4 on the other side, divide by 4, which is 0.5 meters per second. So we say that the gun recoils back with a velocity of 0.5 meters per second, okay, which is not, no, what happens if the mass of the bullet and the mass of the gun were about equal? Then the gun will recoil with a much bigger velocity, okay, which could be very dangerous. So I think that ends this video. We'll see you until the next video.